Greetings in Islam. This is Sister Venus, and in this video we will be reviewing the Pre-Algebra Properties reference sheet that's in the math class directory. These properties are being used in Pre-Algebra this year because the goal of Pre-Algebra is to solve for an unknown. And many times to solve for an unknown, we would have to isolate the variable and use many different pre-algebra properties to successfully solve for the unknown variable. This first property is called the additive identity property. And this means you can add 0 to any number in any equation and it keeps its identity. For example, we have 5 plus 0 is equal to 5. 0 plus 5 is equal to 5. This property is valid for any whole number, negative or positive, and any real number, negative or positive. Right here, A represents a real number, and this reads A plus 0 is equal to A, and 0 plus A is equal to A. It doesn't matter which order that you add the 0 in, whether you add it first or second or third or fourth. This property always keeps its identity if you add 0. So this is a very important property. The next property is the additive inverse property. This property is derived from the additive identity property. So let's look at this example. We have 5, but we want 0. How do we get a 0 when we start with 5? We have to add the inverse. 5 plus a minus 5 is equal to 0. 5 added to the inverse, which is negative 5, will always give you 0. So the inverse of any whole number or any real number is valid with this property. So we have negative 5 plus 5 is equal to 0. And the inverse is also another way of saying the opposite. So the additive inverse of any real number is the negative of that real number, or any integer is the negative. So the property reads the additive inverse of a number A is negative A. So that A plus a negative A is equal to 0, and a negative A plus A is equal to 0. So it doesn't matter which order that you added in, the inverse added to the number will always give you 0. So this is a very, very important property, and we use property since day one of solving math problems here in pre-algebra. So the next property is the multiplicative identity property. This property we have spoke about very extensively, and with this property means you can multiply any number by 1 and the number keeps its identity. So the prior property that we were just talking about was addition. How it kept its identity through addition would be 0. But in multiplication, the identity is 1. So know the difference. The additive identity is 0. The multiplicative identity is 1. And anytime you multiply by 1 to any number, you always get the same number. And we use this in many ways. So this is a very, very important property to use in pre-algebra. We have, for this example, 8 times 1 is equal to 1, or 1 times 8 is equal to 1. So the order that we multiply this 1 in does not matter. So the multiplicative identity property, you can see right here, is valid for any real number, negative or positive, or any whole number or integer, negative or positive. And what this reads is A, which represents a real number, multiplied by 1 is equal to A. And 1 times A is equal to A. And this is often written in one line. A times 1 is equal to A, which is also equal to 1 times A. So make sure you have this pre-algebra properties reference printed out and add it to your notes. So the next property is called the multiplicative inverse property. This property is derived from the multiplicative identity property. And what this says is if we have a number, for this example, 8 times blank is equal to 1. So what do we need to multiply 8 by to get 1? And we already agreed that 8 in the numerator and 8 in the denominator is equal to 1. So any number with the same numerator and the same denominator will always equal 1. Itself divided by itself will always equal to 1. So if we have 8 in the numerator, we need 8 in the denominator to equal 1. And so that's what we have. 8 can be rewritten to 8 over 1. Any number with a denominator of 1 is equal to the same number. So we have 8 can be rewritten as 8 over 1 times 1 over 8. That gives us 8 over 8, and we can cross multiply and cancel out those 8, which will give us 1 over 1, or 8 over 8, which is equal to 1. So the multiplicative identity of any number is that number, and the inverse of that is 1 over the number. So in this case, we have 8 in the numerator, and the multiplicative identity is the same number, 8 in the denominator. So 8 over 1 is the multiplicative identity of 1 over 8. So how do we get the multiplicative identity over 1 over 8 if we want 1 to be the answer? We have 1 over 8. We would multiply it by, you got it, 8 over 1. So you would need 8 over 8 to equal to 1. So 1 over 8 times 8, and we can put an imaginary 1 up underneath it, is equal to 1. So the multiplicative identity of 1 over 8 is equal to 8. And so that's very, very important. Any fraction can be represented as 1. And that means whatever number that you have, you can divide it by itself. For example, if you have 80, if I wanted to represent that as a fraction, it would be 80 divided by 80, which would be equal to 1. If I have 6 divided by 6, that is equal to 1. So that's a very, very important property, and you would use that, and that would justify the way you solve certain equations. Okay? So the multiplicative inverse property is right here, and it says that the multiplicative inverse of a number a is 1 over a, so that a times 1 over a is equal to 1, and 1 over a times a is equal to 1. This is often written in one line. A times 1 over a is equal to 1, which is equal to 1 over a times a. And a is any real number, which can also include negative and positive real numbers, and also include all integers and whole numbers. So when you say real numbers, that includes everything. So we have another multiplicative inverse that we want to solve for. So in this example, we don't have 1, but we have 2 over 5. So the multiplicative inverse would be to flip that, okay? So 2 over 5 becomes 5 over 2, which is equal, when we multiply across, 2 times 5 is equal to 10, and 5 times 2 is equal to 10, which is equal to 1. So the goal of the multiplicative inverse is to have 1. So when you multiply two numbers that are the multiplicative inverse of one another, you would always get 1. Otherwise, you do not have the multiplicative inverse. And we have one more property, and it's called the associative property of addition. And with this, you're adding more than 2 numbers. So when you're adding 2 or more numbers, it does not matter what order you add them in. So in this example, we have 2 plus 3 plus 4 is equal to 9. So we changed the order on, and we added parentheses on how we're going to add these numbers. We have 2 plus 3 plus 4 inside parentheses, so what's inside the parentheses is what you add first. That becomes 2 plus 7 is equal to 9. So we change the parentheses here, and we have 2 plus 3 is in parentheses plus 4. And 2 plus 3 is equal to 5 plus 4 is equal to 9. So this property is very important. It says it does not matter which order and how you group the numbers when you add. We have another example where we group them and we put it all in one sentence, and you're going to get 9 on this side and 9 on this side. So 9 equals 9. So this property is valid. And this property is valid for any and all real numbers and whole numbers. number, okay? So we have another example where we have 1 plus 8 plus 5 in parentheses. That equals 1 plus 13, which is equal to 14. So we have 1 plus 8 in parentheses plus 5. So we combine the 1 plus 8 first, which would give us 9. 9 plus 5 is equal to 14. So we were able to prove that this property is valid. So we'll be using these properties in pre-algebra, and this can be rewritten to the associative property of addition. A plus B plus C in parentheses is equal to A plus B in parentheses plus C. And this is valid for any real number, which A, B, and C are any real number. And this is also valid for any whole numbers as well. So remember that none of these properties for the additive property or the multiplicative property will work for subtract, okay? So you can't subtract out of order, okay? So these properties are only working for addition and multiplication. This is a very, very important reference sheet. Please print it out. Please include it with your notes.